So let's take a look at the Python example for vector quantization in an encoder and a decoder, a complete example. So first I'm going to load now, it's Iron Maiden Aces High introduction. So there is this very famous speech. Let's listen to it.
We shall go on to the end. We shall fight in France. We shall fight on the seas and oceans. We shall fight with growing confidence and growing strength in the air. We shall defend our island, whatever.
So this is the Aces High introduction, and this is going to be our training set. So I'm loading the audio, and then I'm plotting here just the normal waveform, and we can listen to it. But then we are going to convert this into a two-dimensional vector space. So we are reshaping our signal to have two-dimensional vectors, and we see that there's a distribution here in the diagonal. So then we are going to create our codebook, but for that I'm going to use scikit-learn the k-means. So we've seen that the nearest neighbor rule is used, and then we are going to use this already implemented library k-means from scikit-learn clustering. So we are defining a number of bit if equals to 3. So that means that we will have 2 to the power of 3 clusters. So this is what we are doing here. So then we are initializing our data, our model. We are creating a model using k-mean plus initializer. The number of clusters is defined here, and we define a number of iterations, and then we will fit this model using our training data, which is these two-dimensional vectors here. And then so now we have our code book trained here, and here just to plot. So we will have here, this is our two-dimensional vectors, and then we have the Voronoi regions and the centroids marked with this cross here. So we just did what we explained previously, but using this very convenient scikit-learn library. So we are using the k-means to, and here we're just plotting the Voronoi regions. So this is how we do it. So we have this very nice plot, and we can see our code book. So we have 8 values, and these are the centroids. Okay. So now we go, we take indices of our code words. So now our coded signal would look like this. So we are using the nearest neighbor rule. So all the vectors that are near to this centroid, they will be assigned these values. So we are doing this mapping. And on the decoder, we decode indices to vectors. So this is what we are doing here. And then I am just plotting to have the decoded signal. So in this case, I'm just showing you how it would sound. This is we're using this signal as the training set, and then when we encode and then we decode, it would sound like this.
We shall go on to the end. We shall fight in France. We shall fight on the seas and oceans. We shall fight with growing confidence and growing strength in the air.
So we just trained our model to get this code book, and we use this code book. So it's 3 bits, so 8 possible values, and then our signal that used to be this becomes something like this.